All right, friends, we're going to go ahead and do an example with graphing with multiple vertical asymptotes. So here we go. Let's do y equals, let's pick something nice, minus x minus 20 all over x plus 2. All right, so first thing I notice is that the degree of the numerator is bigger than the degree of the denominator. So while I start factoring to make sure that this is fully reduced, I am also going to do my synthetic division in order to write this in, okay, so we've got standard form, we've got factored form, and then I want to write it in the divided form as well. All right, so I'm just going to bring up my scratch paper or my whiteboard here, and 1, -1 minus 20. I'm going to do my division. All right, so that's going to give me, now this was squared, so this is going to be x, number, and remainder. So let's write up our divided format. I'm going to switch the order. Okay, let's do it. Let's write down our characteristics. None. So we're going to have a slant asymptote. That's going to be y equals x minus 3. Comes from this part right here from that synthetic division. Okay, I've got 2 x-intercepts from that factored form there. Okay, and x equals -2. All right, let's put it on the graph. 1, 2. This is x equals -2. 1, 2, 3. And we'll extend this. We got a positive 3. Okay, so I'm going to graph this line. Okay, there it is. Just extend that a little bit. Check, check, points. 3, 4, 5, 6, 7, 8, 9, 10. Okay. 2, 3, 4, 5. Okay. 1, 2, 3, 4. Okay. So you have to stay, right, in your sections. Woo, it's a giant graph. Notice that the only 2 places that we're touching the x-axis are at the x-intercepts. All right, nice job, guys. Okay, now I'm going to go ahead and flip my page, and we're going to do 2 vertical asymptotes. That one was just a quick review. Okay, y equals, I'm actually just going to switch it, see what happens, x squared. Okay, same thing. I'm going to factor it to make sure that it is fully reduced. Okay, nice. And because this is not top heavy, right, this can't be divided because the degree of the numerator is less than the degree of the denominator. Okay, it's like saying 3 divided by 4. That's already a simplified fraction. I cannot divide that. All right, so let's start with our characteristics. It means that there is no divided format. This is it. Okay, that's it. Vertical asymptote. We have 2 of them. Okay, horizontal, this is bottom heavy. So just a quick little reminder that this is end behavior, and because the horizontal asymptote is 0, the end behavior matches. X-intercepts, we have 1, and y-intercept, we have -1/10. Okay, let's put it on the graph. All right, so I'm going to have to count a little bit smaller this time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And actually, I think I'm going to space out my y values just a little more because the graph doesn't have to be perfectly square. Okay. So we're just going to count by ones. I see that y-intercept, that's really small. I wanted to give myself a little bit more space to graph that. Okay, let's start putting these things on the graph. 2, 3, 4. Okay, x equals -4. 5. 0. Okay, and put our points on. -2. All right, there we go. So if I'm looking at this, I have to think about the different sections of the graph. Okay, so I have the outside section. Okay, this is x is less than -4. Okay, I have this little tiny section which is between -4 and -2. Okay, that's right here. Then I have this section here that's between -2 and 5. Okay. Then I have this section here that is more than 5. And you just need to kind of test it to see whether it's going to be above or below the axes. Let's grab that pencil. Let's do a little testing. Notice here that I have 3 factors. So I'm just going to look at each factor to figure out whether it's positive or negative. So I'm going to try -5. So that's, I'll just write it here for closer reference. And I'm going to figure out if each factor is positive or negative. Negative, negative, negative. All right, that makes this result negative. So it's going to be down here. Okay. -4 to -2. So let's try like -3. Negative, negative, positive. Okay, dump doubles. 2 negatives makes a positive. That means that it's going to be up here. Right? Whoop. Shaded a little too much. There it is. Okay. And now let's test between -2 and 5. So let's say like 0, which you've already done, is negative because you already did the y-intercept that's in that section. Okay. And the last section, let's pick like 6. Positive, positive, positive. Okay. So now that we have our sections determined, now you can actually put the graph on there. Now, you've got to stay in the shaded regions because it has to be negative in that section. Now here, we have these 2 points which obviously have to be connected. And as you're looking at this, you can think about multiplicities. This is a single multiplicity for that x-intercept. Means it has to go straight through. And the only thing left is for it to go up towards the vertical asymptote. It can't turn back around because then it would have to touch the x-axis again, and that's not allowed. Similarly, if you're here, okay, the graph can't turn back up because you can't touch the x-axis again, which means the only choice is for it to stay down in this negative section. And then here it's positive, which means all your outputs need to be positive. All right, let's do one more with 2 vertical asymptotes. Oh, okay. I have a really good one. Let's do... Okay.
10.
Yay.
So 110 plus 30 plus 10. So that.
Okay, this one's going to be kind of fun, I think. I'm going to go ahead and do some factoring. And because I feel like it's more than one step, I'm going to just grab my little scratch paper or my whiteboard, and I'm going to do my factoring. I'm going to take that common 3 out. Okay, then I get positive 3, negative 2. Not exactly what I wanted. Let's go ahead and, I don't want a hole. I don't want a hole. So let's make this. Okay. Thinking. There we go. We'll make that a 3x. Okay, so now we factor this. Now, I could do the division because it's balanced. I don't really need to, but I could. All right, so then I'd actually have to do long division. So I'm not going to. All right, here we go. Let's write out our characteristics. Okay, vertical. X equals 0, x equals 3. Y equals 3. Look at that balance. So just for a reminder, okay, that's the end behavior. X-intercepts, we have 2 of them. Okay, and here we go. Y-intercept, undefined. Okay, so let's see what this looks like on the graph. 1, 2, 3. Okay, so there's my horizontal. Y equals 3. Okay, here's my vertical. X equals 0. 1, 2, 3. Here's my other vertical. X equals 3. 2, 3. 1, 2. Okay. Here we go. Now, thinking about these sections, okay, I have, okay, x less than negative 3. Then I have between 3 and 0. And then I have between 0 and 2. And then I have between 2 and 3. Okay, and then I have x is more than 3. So I've got quite a few sections here. So I'm going to start thinking about multiplicities as well. Okay, now I've got 3, x plus 3, x minus 2, x, and x minus 3. Okay, so I've got a positive, right? This 3 is always positive. And let's try this. Negative, 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 negative. Okay, so that's positive. Makes sense. So I have to go through this, which is a multiplicity of 1. And it has to be positive in that section. Okay, now I'm going to test here. I'm going to try like negative 1. So this is positive, negative 1. So it's positive, negative, negative, negative. Okay, so that makes negative. Means it's going to come down. Notice that it's still following that parent function shape. Okay, this is, write that result there. positive, negative. Okay, now between 0 and 2, so I'm going to try 1. So this is positive, positive, negative, positive, negative. Oh, that's positive. Okay, so we have a positive result. Now, notice that this is a multiplicity of 1. Okay, so it has to go straight through. So it's either going to go like this or like this. Because this section is positive, it has to be positive, and you do have to approach those asymptotes, right? Okay, so now I'm going to check between 2 and 3. Although, because the multiplicity is 1, I have to go straight through. I'm almost certain this piece has to be negative, but I'll check for sure. That's going to be a 2.5. So that's positive, 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 negative. Aha, so it is negative. Okay, and then more than 3. Well, I really don't know, so let's check. This is positive, 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 positive. Okay, so it's positive. All right, now you kind of have a choice here. It just has to be positive, okay? Which means as I look at how to place my shape, okay, I have a couple different choices. And we're just going to pick one of the simpler choices, okay? I know because of end behavior that the arrow has to go towards, here. Okay, but it has to be positive. So it can do this. Okay, a little weird. Okay, but what can't it do? It can't do this because notice that that would be in the wrong section. It can't go down here, which means if you have to go to this vertical asymptote, it has to go up. Okay, so it can go like this. It could go like this. Okay, but there's no reason to make it funky. This is just a sketch, so we're going to keep it in the top right section. Whew, fun.